Hello, geometry, and welcome to the last video of Unit 7. We're doing law of cosines. We just got done with law of sines last lesson, law of cosines today. So why is using the law of sines? Now, I know we're doing law of cosines here, but I'm showing you why we need another law. The law of sines is not possible for the following triangle. Let's try and do law of sines. If you remember that from the last lesson, we're looking for x. The angle across from it is 39. So x over the sine of 39. Well, the other information that we have, I've got 21, which is a side, over the sine of b. Well, that's two variables. I can't do that. Well, let's do the other one. We have that 42 there, right? So 42, but that's across from c. I have no way of solving this using law of sines. So we have to use a different tool. Enter law of cosines. Now, the law of cosines looks pretty disgusting. They all are actually saying the same thing. You don't need to memorize all of them. You just have to know one of them, and it'll be on your formula sheets and on your tests. But there are some things that you need to see. So really, all you need is one of these if you understand the relationships. I talked about this one last time. Lowercase letters represent sides, and uppercase or capital letters represent angles. Notice there's only one angle in the formula, right? In all of these, cosine of A, cosine of B, and cosine of C, they all happen at the end, okay? This next part is one that I really want you to see. The side that is by itself, so that's the one that's over here all by itself, matches the angle at the end of the formula. So the side that's by itself matches the angle at the end of the formula. Okay. The other two sides are in the b squared plus c squared minus 2 side portion of the formula, that middle portion of the formula right there. So if you look at it, a is by itself on the first one, cosine of a at the end. B and c are all in the middle. B on the second one, b is on by itself, cosine of b at the end, a and c are in the middle. C at the beginning by itself, cosine of c, a and b are in the middle. All right. That relationship, those relationships are huge. Okay. Use the law of cosines to find the value of x above. So I'm going to just go up here and do it. Oops. I'm going to go up here and do it. Since it's got the formula and the picture. So I'm looking for x, which is a side. So it's going to be by itself. And it's b and c are just the opposite of the other two sides. So 21 squared plus 42 squared. So it's kind of like Pythagorean theorem a little bit. Minus 2 times 21 times 42 times the cosine of the angle, which is 39. Now, if you look at, that's a lot there. There's a lot there. But if you look at it, everything there is a number. So in reality, you can actually just type this whole thing in the calculator. So 21 squared plus 42 squared minus 2 parentheses 21 close parentheses 42 close parentheses cosine 39, and you get 834.114, right? I don't want to round it though. Don't round this. Notice we're not done. I have x squared. How do I get x squared? Oh, the squared away. I got to square root that. So again, I'm not clearing anything. I get second x squared, which gives me the radical, and then second negative, which takes that answer and puts it in. And I get 28.88. So x equals, I don't remember what I said, 28 point, usually it's the nearest 10th. 28.9 is x. Okay. And that's how you do law of cosines. Now that was an easy one. Next one here is not so easy. Now we're looking for an angle. All right. So angle L, I'm going to put an X there. Again, can't use law of sines here. But which side is by itself? Because you got all three sides there. Which side do I put by itself? Does it matter? It does. If I wanted to find angle M, I would put 8 by itself. If I wanted to find angle N, I would put 12 by itself. If I want to find angle L, I'd put 10 by itself. That's understanding the relationship that I was showing you with those formulas. So I want to find angle L, so I'm going to put 10 by itself. The other two sides go here and here. Those same two sides go here and here. But now we have the cosine of x. This one's harder because you cannot just put it in the calculator. You can put a lot of this in the calculator, but you can't put all of it in the calculator. So 100 equals 64 plus 144 minus, and I'm going to do 2 times 8 times 12. That's 192 cosine of x. I'm going to add 64 plus 144. I get 208. And this is usually where the mistake happens, right here. I have a ton of people who subtract 208 and 192. You cannot do that. I cannot say 16 cosine x. Okay. If you say that, I'm going to write it. That's the number one mistake people make. You cannot do that. Reason? That's like 208 minus 192x. If I had it like that, you would know not to subtract those two. You would have to move the 208, which is what we need to do. We need to subtract the 208 from both sides. So I get negative 108 equals, and that's negative 192 cosine of x. Divide by negative 192. And I'm going to now have negative 108 over negative 192. If you want to make them both positive, that's fine because two negatives cancel. Equals the cosine of x. And like you're used to, we should be doing the inverse cosine of that fraction. And I get 55.77 to the nearest tenth of a degree. It'd be 55.8 degrees. Okay. So that's law of cosines when you're finding an angle. All right, last problem. Find all of the missing pieces in this triangle. Give angle measures to the nearest degree and side lengths to the nearest hundredth. So I try to do law of sines. Okay, now this is one of those that's going to combine law of sines and law of cosines. I'm going to try and find law of sines, and I'm going to see that I can't do it. If I try to find angle A, I would have I have no angle or side across from it known. Right. So if I tried to find angle A using law of sines, it wouldn't work. If I tried to find angle B using law of sines, it wouldn't work yet. If I tried to find AB using law of sines, it wouldn't work yet. All right. So what I need to do is law of cosines first. So law of cosines, let's find AB first. So actually, I'm going to do something here real quick. Make this a little bit smaller so it all fits on the page. Okay, there we go. All right, so we're going to find AB first. So x is going to be by itself. The other two sides, 5 squared and 16 squared, minus 2 times 5 times 16 times the cosine of 61. Again, this is one of those where you can just type it all in the calculator since the variable is by itself on the left. So 5 squared plus 16 squared minus 2 times 5 times 16 times the cosine of 61. And you should get 203.43, but that's x squared. Now I'm going to do square root of that number. And I get 14.26 or 14.3. So the first missing piece was side AB. And it was 14.3. All right. Now, before I go any further, what you should see is that angle A is across from a 16 and angle C is across from 14.3. 16 is bigger than 14.3, so angle A should be bigger than 61. It's a good thing to kind of watch out for. Okay. Now, I'm going to tell you something here. You should only have to use the law of cosines once in a problem. You should not have to use it twice. I now have enough information to do the law of sines, which is what I'm going to do. So this is 14.3. Okay. And I'm going to find the other missing piece. Now, I can do either one next. It doesn't matter. It could be angle A or it could be angle B. It doesn't matter. So I'm going to do 14.3 over 61. And the reason I'm able to do a law of sines now, sorry, sine of 61, is because I have a side and the angle across from it known, which allows me to do law of sines. I'll do angle B first. So 5 over sine B. So this is review of yesterday. So 14.3 sine B equals 5 sine 61. You might have remembered in the last lesson I said don't use a rounded number if possible. This is one of those cases where it's not possible. You have to use that rounded number of 14.3. So you just do it if you have to. But if you can avoid it, avoid it. That's what I was trying to tell you in the last lesson. All right, so I've got the sine of B equals that right there. Tried this yesterday. Try it again. I'm doing it right now on my calculator, and I get 0.305. That's what the sine of B equals. And then I'm going to do the second sine of that answer. Not going to click. So I get 17.8. Now that's an angle measure. So angle B is a whole degree. 17.8 would be 18 degrees. And now you're going to do angle A. Now, what are you going to do for angle A? Hopefully you catch on to this. You don't have to do either law of sines or law of cosines. All you have to do is do 180 minus 18 minus 61 to find the missing piece. And you should get angle A equals 101. We are going to work on when to use law of sines and when to use law of cosines and when to use right triangle trig in upcoming days. But we're going to work on law of cosines tomorrow. If you have any questions, let me know. And that's the end of this unit.